Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video we are covering CCNA Semester 2 Routing and Switching Essentials. This is Chapter 5 Inter-VLAN Routing. Chapter 5 is separated in three sections. We have Section 5.1 Inter-VLAN Routing Configurations, then Section 5.2 Troubleshooting Inter-VLAN Routing, then Section 5.3 Layer 3 Switching. Section 5.1 Inter-VLAN Routing Configuration. Upon completion of this section, you should be able to describe the three primary options for enabling inter-VLAN routing. You should be able to configure legacy inter-VLAN routing and configure router on the stick inter-VLAN routing. What is inter-VLAN routing? Layer 2 switches cannot forward traffic between VLANs without the assistance of layer 3 device like a router. Inter-VLAN routing is a process for forwarding network traffic from one VLAN to another VLAN using router. We have legacy inter-VLAN routing. In a legacy inter-VLAN routing, we obviously use the router, but the switch connected for each VLAN, the router had to have an interface. So for example, here we have VLAN 10 and the FA01, 00 of the router is going to be on that VLAN, and VLAN 30, FA01 on the router is going to be on that VLAN. So if we create another VLAN, we have to create add another interface. Another VLAN, another interface. You can see it's not scalable because router, by default, it has two interfaces anyway, but you can add more. It's just that it's not very scalable this way. Or the second type is router on the stick. Router on the stick, it got away from that each one interface for each VLAN. Now we have only a single interface. A single interface. On that single interface we create sub-interfaces. So for example, as many VLAN as we want, we can create sub-interfaces for that. Well, around 4 billion. So we're never going to reach that number anyway, but so we can have sub-interfaces. The disadvantage of router on the stick is that this here, if I mark it here, here's going to be your bottleneck, because as the packet come in, right? Let me go back to the legacy inter-VLAN routing. If I go here, the packet from VLAN 10, this PC will send it to the gateway. So is it going to the gateway, right? It's going to the router here. Router will do the routing, find out that its exit interface is FA01, and it will send it out of the second interface towards this PC here. On the router on the stick, we have only one interface, and we create logical interfaces for each VLAN. Now, as the PC1 in VLAN 10 sends a packet towards the router, go in that logical interface in, we'll do the routing, and when it will come back as exactly the same interface, well, it's logical different interface, and out of the VLAN 30. The problem here is that this interface is going to get very busy, very congested, because all the VLANs are going to go here. So you can create, like for example, 100 VLANs, but the bottleneck of your network is going to be on this interface. Solution to that will be switched virtual interface. Now the switch will create a virtual interface for each VLAN that it has. They're called switched virtual interface. But this has to be a layer 3 device. So for example, if we have a VLAN 10, we create one SVI for that VLAN. So as the packet come in from this PC on VLAN 10, they go on that virtual interface here inside the multi-layer switch. Then it going to go out of the other virtual interface and out of the other port to get to the VLAN 20. Switch virtual interface. Everything in the memory, not physical here. All these switch virtual interfaces are in the memory. So legacy inter-VLAN routing is used to route between VLANs. Each VLAN was connected to a different physical router interface. Packets would arrive on the router through one interface and be routed and leave throughout another interface. The router interfaces connected to VLAN have an IP address from that specific VLAN. Large networks with a large number of VLANs require many router interfaces. So what will happen, like I said, PC1 sends data. It's going to go towards the trunk link and then towards the first G0 interface. Be routed on the router, find out the exit interface, and it will find out that it's G01 and be routed out of the second interface. Again, scalability, big issue here. So for example, a router is required to connect routes between subnets VLAN. So we have, for example, the VLAN here, the blue VLAN on this side is connected to this interface. This is a gigabit Ethernet interface on the router, and the red VLAN is connected to the other one, G00. So the packets, they're going to come from the blue VLAN, they're going to go out of this interface, or in this interface as a gateway, and then the red VLANs, this is going to be the gateway. So each VLAN has its own interface. To configure it, first you have to go to the switch, and you remember the configuration, how we create the VLANs and how we add the ports to the correct VLAN. So VLAN 10, for example, say and VLAN 30, we created two VLANs, 10 and 30, as required there. Then we type fast Ethernet 011, so this is the port here connecting to this PC, and we do switchboard mode access VLAN 10 or switchboard. To create, we need to tell there's an access port, yeah. So switchboard mode access first, that's what is not displayed, and then switchboard access VLAN 10. We put in this port here on VLAN 10, so VLAN 10. Then we do the same thing for port 4. We put that port on VLAN 10 as well. So these two are in the same VLAN. FA06, put in VLAN 30, so FA06 on 30, and then FA05 on 30 as well. So as far as the router and the PCs are concerned, there's no any other different or special configuration. It's all the switch what is doing. It's putting in all these ports like this, separate on VLAN 10, sorry, and then this and VLAN 30. So interface G00, you just give an IP address, nothing special there, 172.16.10.1 and /24, no shutdown. And then we go to the other interface, we give an IP address. The PC1 and PC3, they're going to use that as a gateway. When we do show IP route, if we watch the videos, chapter 4, you should be very familiar with this. Now they're in the router, we see two entries for each network. We see connected and local interface IP address. Router on the stick. Now the router has to be part of this. Now router has to, you have to do the configuration on the router. Before it didn't do anything. Everything was in the switch. It's only VLAN. The router on the stick approach uses a different path to route between the VLANs. So as one packet comes in one interface through physical interface, one interface with different logical interface, they're going to go out of the different logical interface. So one of the router's physical interfaces is configured as 802.1q trunk port. So it's going to understand the VLAN tags. Logical interfaces then are created, one sub-interface per VLAN. Each sub-interface is configured with an IP address from the VLAN it represents. So VLAN members hosts are configured to use the sub-interface as a default gateway. Only one of the router's physical interfaces is used. Here we can have a scalability here, but there's a problem with the bottleneck. So for example, in the switch we say VLAN 10 and VLAN 30, and then we put the ports in the correct VLAN, switchboard access VLAN 10, and we go to port 6 and we say switchboard access VLAN 30. This command is very important. Interface FA05, the interface is connected to the router, and needs to create it to make it switchboard mode trunk. So make sure that we type switchboard mode trunk, so the switch knows that this is going to be trunk. It's going to send tagged information. And on the router, we go to the one of the physical interfaces. So for example, interface G00, and then we say dot. If you hit the question mark here, you can have 4 billion possibilities, over 4 billion. But dot 10, this doesn't really mean anything. It's just for us, it's easy to identify, okay, this interface is for VLAN 10. You can put any number that you want. And then this is important though. We have to say encapsulation .1q. This binds it to VLAN 10. So now, okay, we know that this sub-interface is for VLAN 10. This here, you can put any number that you want. It doesn't mean anything, right? You can put anything. This is very important. This binds it to VLAN 10. So you have to give an IP address, same as on VLAN 10, 172.17.10.1. And for this PC, that IP address is going to be the gateway, the default gateway. Do the same for G0/0.30 dot, tells it it's a sub interface, yeah? We bind it to VLAN 30.1q 30, give an IP address on that range on the network 30, and then interface G00 in the last thing, we need to not shut down the physical interface. So interface G0/0 not shut down. Show VLANs. We can see that on the router now we have two separate. If you want to see what sub interfaces we have one sub interface for VLAN 10 and one sub interface for VLAN 30. Show IP route. Again, we can see 4 entries, 2 for each network. So the router on the stick configuration, the whole thing is, if you go to the switch and say interface G gigabit 11 switch port mode trunk, so you need to enable this on the switch. That's it. And make sure that you put these ports on the correct VLAN. Yeah, so you have VLAN 10 and VLAN 20 in this case. On the router, you see no shutdown on G00. It will not show on the running configuration. Then you have to go to the interface gigabit 00 here, this interface here. I know it doesn't match in our screen here, but G00 is here, and then we create a sub interface. .2, for example, with description, describing that it's for VLAN 2. Encapsulation .1Q, and then 2 that binds it to VLAN 2. And native, it means that the traffic they send to this interface on this sub interface is not going to be tagged, and we give an IP address. You can't give an IP address first like this. You can't do this first and then encapsulation second. Not allowed. It will give you error if you try and give an IP address without telling the encapsulation first. So .10, for example, they create another sub interface, and we are binding it to .10, given the correct IP address. .20 again. We binding it here to VLAN 20, same IP address on that range. You can do the whole thing for every different kind of VLANs you have on your configuration. Thank you very much for watching this section, which is 5.1 Inter-VLAN routing configuration. Please have a look at my other videos and don't forget to subscribe. This has been Astrid Krasniqi. Next video, 5.2 Troubleshooting Inter-VLAN routing. Bye bye.